Today's video will demonstrate how to integrate the various components to the separation of concerns design patterns. Hello, I'm James Helfrich. The separation of concern design patterns separate a program into three components: storage, business logic, and interface. But how do you integrate those three components? Well, there are several different ways to do it. This video will explain each, as well as describe the pros and cons of them. Most classes do three separate things. They store things, they have a convenient public interface, and they represent a logic that manipulates the data. Now, the whole process of separation of concerns is to separate these three concerns into three separate classes. We're going to start with the storage, and this is going to store all the data the class is meant to represent. Next, we're going to have the business logic, and this is the rules governing the management of that state. And finally, the interface, and this is a convenient interface so the client can integrate this class into their application. Now, it's one thing to separate these concerns. It's the second thing is how do you put them all together? And that's what we're going to talk about today. With the three concerns separate in the classes, how can they be reassembled? And we have several different options. The easiest and perhaps the most intuitive is linear composition. In other words, when I instantiate an interface, and I automatically get a business logic, which then automatically gets a storage. And these are all connected through composition. The next one is linear aggregation. This is the same as linear composition, except the interface does not instantiate an object, but rather links to it. And this makes it easier to reuse the business logic and reuse the storage for multiple interfaces. And next, we're going to have circular integration. In this case, the interface is going to communicate directly with the business logic. The business logic will then send information to the storage, and the storage will send information directly back to the interface. The next one is an ad hoc, and here I don't really have a plan. I'm just going to make connections happen willy-nilly. And finally is the model view controller. And this is a composite design pattern where the storage is going to talk to the interface through the observer design pattern. The interface is going to send information directly to business logic, and business logic will send information directly through the storage. Okay, let's take a look at each of these in turn. First of all, linear composition. As I mentioned previously, this is perhaps the easiest to understand. We're going to start with a data flow diagram. Now we're going to start with the interface, and the interface connects to the client directly. And then the interface is going to connect with the business logic directly. And then the business logic is to connect to the storage directly. Now observe, if the client wants to store data, it has to go through the interface, which makes sense. It's the public interface for the client, which then goes to the business logic, which is going to validate the data, and then gets sent to storage. Now, of course, if the client wants to request data, it has to go through all these stages again. It has to talk to the interface has to talk to the business logic is going to get the data from storage and then send it back to business logic, then it send it back to interface, and then send it back to the client. And this whole thing is called the linear composition integration. So how are we going to build this? Let's take a look at a class diagram. I'm going to have the interface, the business logic, and the storage, of course. Those are going to be my three classes representing the three concerns. Now, the interface is going to connect to the business logic directly. It's going to have a logic attribute, which is of type business logic, and this is through composition, and there'll be exactly one. In other words, when we instantiate an interface object, we will automatically get a business logic, and then we destroy our interface, we automatically destroy the business logic, and there's a direct connection between them. Now, the business logic is connected directly to storage, and once again, the business logic is going to have a member variable type storage, and it's going to be through composition, and there's going to be exactly one. So when I instantiate a business logic object, then of course I get a storage for free. And of course, when I free my business logic, I free my storage. Okay, the next strategy is linear aggregation. And it's going to be very similar to our linear composition. In fact, the data flow diagram is going to be identical. I'm going to have my interface, my client talking to each other directly. The interface is going to talk directly to the business logic, and the business logic will talk directly to storage. And this, of course, is called linear integration. Now, how are we going to connect these? Well, my interface and my business logic and my storage are going to be connected just like before. And I'm going to have interface talking directly business logic. And so my interface is going to have an instance of business logic, but not just an instance, but a reference. In other words, the interface is not going to create or destroy the business logic, but then reference an existing business logic. Therefore, I'm not going to have composition, but I'm going to have aggregation. And once again, there's going to be exactly one. And the same thing is true between business logic and storage. Business logic is going to be connected directly to storage, but will not create or destroy the storage. So business logic is going to have a reference to storage as an attribute. And since it's a reference, this can be aggregation. And once again, there's going to be exactly one. Now, we're going to have the same issue we had with linear composition. Namely, if the client wants to get data from storage, it has to first talk to interface. Interface will talk to business logic. Logic will talk to storage. And then storage will respond by sending the data back to business logic. And business logic will send the data back to interface. And interface will send the data on to the client. Okay, there is another strategy called circular integration, and this is going to be a little bit different. So let's start once again with the data flow diagram. We're going to start with the interface that talks directly to the client, and then the interface is going to talk to the business logic in a one way. In other words, the interface is going to send data to the business logic. Then the business logic is going to talk to storage one way. The business logic will send data to the storage. And this kind of makes sense if you think about it, because we really want all data that go to storage to be validated through the business logic. Now, how is data going to get from storage to interface? Well, rather than going back through business logic, it's going to talk directly to interface. And this whole thing is called circular integration, and observe how we form a circle. In other words, when data goes from storage to interface, it doesn't have to go through business logic again. Well, how do we skip that step? Well, let's take a look at this. So once again, we're going to have the interface as a class, the business logic as a class, and the storage as a class. Now, the interface is going to have an instance of business logic, probably a reference, but it could be composition. It doesn't matter which. And it's going to have exactly one. And the business logic is going to have a reference to storage. It could be one, it could be many, it could even be composition. And now the storage has got to know to send data to the interface, which means the storage has to have a reference to the interface. And it could be to many interfaces. It really depends upon the application. And so that's going to be by aggregation. Perhaps the most common integration strategy is ad hoc. This usually happens when someone doesn't have a plan. Oftentimes, people use ad hoc integration when they think they're doing model view controller, not realizing the model view controller has a very specific integration strategy. So we're going to start with the interface. It's going to talk to the client as usual. Then we're going to have the business logic, which talks to the client going both ways. Then we're going to have the storage, which talks to the business logic both ways. But the storage can also talk to the interface both ways. And this whole thing is called ad hoc. Now, there are many variations. For an example, there might be the case that we only have a one-way row between the interface and the business logic, or it could be two-way. Ad hoc means we don't really have a plan. So let's take a look at the class diagram. We're going to have the interface, the business logic, and the storage. There's going to be a connection between business logic and interface, which means both interface has to have a reference to business logic and business logic has to have a reference to interface. Same thing is true between business logic and storage. Both of them can talk to each other both ways, which means business logic has to have a reference to storage and storage has to have a reference to business logic. It could be one, it could be many. It really depends upon the specifics of the application. And finally, interface and storage can communicate with each other, which means interface has to have a reference to storage and storage has to have a reference to interface. But this means that any concern can talk to any other concern at any point in time, which could yield a little bit of chaos, and hence we're going to call it ad hoc integration. The final integration strategy is the model view controller. And this is a form of circular integration, except we have a very specific communication between the storage and the interface. And that storage is called the observer design pattern, making this a composite design pattern, design pattern built from other design patterns. So this time, in order to explain it, we're going to start with the class diagram. We're going to have the interface, which the model view controller calls the view. We're going to have the business logic, which model view controller calls the controller, and then we're having the storage, which is called the model. Interface has a reference to business logic, as you'd expect, and there's going to be exactly one. The business logic also has a reference to one or more interfaces, and this is done so that the business logic can notify interface that something needs to happen. Now, there is a one-way communication between the business logic and the storage, and so there's going to be an instance of storage, or it could be even a reference to storage from the business logic. Now, here's the complex part. The relation between the view and the model, otherwise known as the interface and the storage, is the observer design pattern, which means that the storage is going to have a collection of interfaces, and each one of them will be notified if something in the storage had changed, which means the interface is going to obtain updates in an asynchronous way, which might not be what's expected. Okay, let's take a look at the data flow diagram to see how they relate to each other. So we're going to have the view, the controller, and the storage, otherwise known as the model. Now, data is going to go from the interface to the business logic, which kind of makes sense. And then also, we're going to notify the interface that display needs to be updated through the business logic. From the controller to the model, data goes directly down, new data goes to storage as one would expect. But now we're going to have a observer design pattern, which is going to go between the view and the model. And how's this going to happen? Well, the view is going to get notified that data got updated, and that's going to be through the observer design pattern. But the view also has to subscribe to the model to let it know it wants that information. And this whole thing is called the model view controller. And of course, the client is always going to speak directly to the interface both ways. You can learn more about the integration of views in the integration of views section of the separation of concerns chapter of the software design textbook.